Speaking the truth to the state capitol, this is Drive Time Lincoln with the Commander, Jack Riggins, on the voice of Lincoln, 1499.3 KLIN.
All right, folks, Friday, November 18th. I'm your host, Jack Riggins, restoring American values, bringing some common sense and a little sanity to the capital city. Johnny Cadillac's producing the show. We got a short show today due to Husker volleyball. We'll expect a big win out of the girls because we should, and they normally deliver. But for those of you that get into the Iowa-Nebraska thing, there you go. Tonight's a good night, chance to talk crap to your Hawkeye fans and brothers, if you will, brothers and sisters. Anyway, we'll talk about it next week more, but finally, provisional ballots have been counted, and it appears that at least here in Lancaster County, and most of Nebraska as it's being reported, all of it's done. It's all done. The races are done. There were no real significant flips over the last batch, the provisional ballot batch. And so we will make sure we kind of run through that probably Monday and Tuesday next week. Now that, quote unquote, the official election counting is over, they still have to certify. But for those of you that were waiting on pins and needles, that is the word. Provisional ballots are done being counted across really Douglas and Lancaster, which with all the people was probably the hang up. And again, nothing to report in a flip, if you will. Closing margins, yes, but nothing that changes what you already knew yesterday. So we will move on. I am very happy to have my good friends from Oak Observatory back in studio. And you know, anytime they're in studio, that means there is some kind of star party event coming up probably this weekend, guys.
That's right. Thanks so much for having us.
Yep, thank you
I
very
love
much.
having you.
Jack.
I've been building a computer. Haven't built one since it's been 20 years. The last one I built was each individual part shopped on the Seoul Electronics Mart in Seoul, South Korea. So if you've been there, there's about 20 electronics markets where you can just pick up your processor and your motherboard on the street. Mm-hmm. Literally, it's well worth it if you're into electronics to peruse the electronic markets.
Wow.
And before that, I had, after college, built one out of Fry's Electronics in San Diego, California, where it's a more American style. You get a bunch of electronic parts. And so finally, I guess I felt my kids were raised enough. It's getting cold enough outside that I would start to rebuild a new and better system. And it never ceases to amaze me that things that little can do such amazing things. Which then brings me to, and then there's the universe.
Yeah.
And you've got the expanded large universe, and then you've got, the inside of silicone universe. Two opposite ends of the spectrum there. But both fascinate me, guys.
Well, thanks again for having us.
Yeah.
And you're absolutely right. Every time we look deeper and deeper into space, the further back in time we're looking, the more galaxies we see, and each one of those galaxies with hundreds of billions of stars. Just recently, of course, with the James Webb Space Telescope, them dropping the very first image that it saw was a quote-unquote deep field image, which these are the images that made Hubble famous, were these deep field images, these images where the telescope is playing the staring game with the universe, staring at a particular spot for as long as it can, and then essentially developing the film, so to speak, and looking at the number of points of light. Well, the James Webb Space Telescope, in just 11 hours, it was able to outperform what the Hubble Space Telescope did in 26 days. And that was its very first try.
That's an improvement.
And not only did it see a little bit deeper, but it was able to, well, its eyes see in infrared light, which not only is infrared heat energy, but the reason why it's so sought after is that because of the expansion of the universe itself, because of basically a cosmological redshift, many of these things that are extremely far away are shifting to different wavelengths. And so things that might have been UV or might have been visible are now only visible in the infrared. So that's why it's such a great
so
telescope.
This drop is probably both a smorgasbord for scientists and astronomers and anybody interested in space exploration or just, understanding it. I mean, we're at one apex, which the apex is only going to get better with the information. I mean, are people just kind of slobbering over themselves about this?
It just seems every week we see something new coming down from the James Webb. One of my favorites, of course, it's taken some great images, not only of the distant universe, but also of our own solar system. It's kind of pointed at some of those planets. But my favorite is it was a second deep field. And in this deep field, they saw a gravitational lens effect where a galaxy was stretched beyond recognition, not physically, not literally, but just as that light is traveling through warped space like a funhouse mirror, it's stretched. Well, something amazing happened. Within that stretched area, there were these little pockets of magnification. It was like the universe provided us a little magnifying glass to see globular clusters within a galaxy that's on the edges of the visible universe, which is something you shouldn't be able to do. And one of the objects that they saw, they believe, and of course, more studies need to be made, but they believe it's an individual star. So this object, if it is what they think it is, its name that goes by Earendel. Earendel is the most distant individual star ever observed in the universe.
Wow.
And what's really exciting about that is that astronomers, when we were talking about the development of the universe, the very earliest stars were these population 3 stars, almost kind of a mythological beast in the world of astronomy.
A unicorn.
It's a unicorn, and you're not supposed to see these unicorns. And some people wondered, could Earendel actually be one of these things? And at about 12.7 billion light years away, probably not. It's probably not quite far enough away. But it does go to show that sometimes the universe does hand you things on a silver platter, and we need to start looking for more of these little, these areas, these pockets of magnification within gravitational lens effects that might allow us to see these population 3 stars that we never thought we'd actually be able to see. Just a kind of a thing of mythos we might actually see. It's exciting. And of course, the thing that's most exciting is what we don't expect. Those things that we never dreamt of.
Right. I mean, as it comes in, I just feel like there's going to be these type of aha moments, these unicorn moments, probably once a month, maybe more than that as it gets really operational and up and just going.
And it will.
Yeah, that's incredible. Yeah. Well, Matt, what's the event you got going on?
So coming up tomorrow, we have our year-end star party, and that runs from 8 p.m. until 11 p.m. It will be cold, so make sure that you're dressing appropriately. And our community superstars are going to be farmers and ranchers.
Okay.
And so if anybody current, retired, are in that particular genre, we actually have 2 opportunities here. We have an online, go to our Facebook page, and you can register online. We're going to have an online drawing, and then we'll have our in-person drawing. So if you come to the event and you're a farmer, rancher, current or retired, you'll get a ticket. And about halfway through the event, we will go ahead and poll for those that are going to brave the elements coming up here tomorrow evening. And then, of course, the online one's going to happen irregardless of what the weather is doing. And so we're very pleased and we're very thankful for our supporter with Security First Bank, Lisa Workman. They've just done amazing things to help support the observatory. And speaking of which, we have a number of things that are going on. The base and the first tower section for the Earth, Moon, Earth is in place, and we're just waiting for some weather that will allow us to continue that build. And I'm hoping that maybe this next week here with the nice weather, with me, of course, I'm taking a week off here, so there might be an opportunity for us to get that all up in the air. And then we just had our initial fundraising event for our multi-purpose center. And that's exciting to think. And speaking with the general contractor, we're looking at breaking ground here in December. And we hope to have everything up and running by May. And we do need your support with that. We got a little ways to go raising some money. So if you go to branchoakobservatory.com, click on our support button, our tab, and then scroll down to the bottom and give generously. This is a great time of the year. A lot of folks get RMDs, from their 401ks and IRAs and other investments. And if you're looking for a place in which you can place your investment, invest into the future of our kids and those young at heart, to be able to get them interested into the sciences, into astronomy, into technology, engineering. We need engineers, we need astrophysicists, we need scientists, we need people who are going to embrace science, and we want to be that initial step for them.
Well, and we need people with brain power and the passion because, no offense, Michael, to you, Matt, and myself, but guess what? The next generation is going to get a heck of a lot more data and information to chew through.
That's true.
And that's awesome. I mean, they should be excited about it, and we'll get a kind of pass the torch and watch as our brain housing group slows down a little bit. But folks, just a great field to get into. Did you guys realize? You probably did. I just realized. Your acronym is BOO.
Oh, yeah.
Boo.
I love acronyms, and so now I can just say, yeah, the fellas out at BOO.
That's right.
The BOO. Out at BOO. I love it.
For a number of years, we had an event that was during Halloween that was Boo at the Boo.
Sure.
Halloween just seems to be the appropriate time for this.
Absolutely
for sure.
appropriate, yeah.
No, that's great. I had two questions. Michael, as we were talking, have we identified, I suspect through calculation, where actually the Big Bang started? Meaning, we talk about expanding universe, and I've always had this question, and I use the beach ball analogy of it's just a beach ball and it's just all going away, right?
Yeah.
But with all this data and everything and all the great minds on it, have we at least got kind of a pinpoint area inside the beach ball?
Yes,
we think
as a matter of fact, it is right here in Nebraska. Ainsworth, Nebraska. In fact, actually, it's funny that you should mention this, because we just finished up in my astronomy class at the university. We finished up on cosmology, and we didn't have this planned. You just asked this out of the blue, it just turns out that I happen to have a pretty good spiel on this very topic. So when we talk about the expanding universe, right after that moment of the Big Bang, we're not talking about material expanding within a bottle. We're talking about the bottle itself expanding. So the very first instance that we really got an idea of this expansion was with Edwin Hubble, the gentleman that the Hubble Space Telescope was named after. And he was able to see a correlation between the redshift, how fast something was moving, to its distance. The more distant an object was away from us, the faster it was moving away from us. Right. And it gives you that impression that if everything's moving away from us, we must be the center of the universe. And of course, we sure like to think that. Right. But the analogy that we commonly use is the raisin bread analogy. If you think of a raisin inside of a loaf of raisin bread that is rising both before it's baked and when it's baking, to each one of those raisins, every other raisin is moving away from it. This is called the cosmological principle. Okay. No matter which direction you look in the universe, you see essentially the same overall density. Not the exact same galaxy.
Everyone, everything, every place is the center of its own universe.
Yeah, or the center of the universe. So you can really say it in two different ways. One, you could say there is no central point, or you can say every place is that central point, because every place was all constricted into that single point.
Could you make the scientific, this is a legitimate question, might be dumb. can you make then the scientific argument that there is no center to the universe, that the universe itself is both expanding, but I guess what I want to say is centralized in the sense that because of that observation thing, we know it's expanding, but it will always expand, what we think, and so therefore there isn't a pinpoint.
Right, there isn't. Everywhere is that center.
Right.
And as far as the expansion to the universe goes, of course, it was first discovered with Edwin Hubble, and then later we discovered the cosmic background radiation as well. And with that, the kind of lost my train of thought there, but with that, we were able to determine, and we were saying, I'm sorry,
that it was everywhere is the center, and we can't really pinpoint one place.
Yeah, we're not able to
because
pinpoint that one area.
everywhere is given the dynamic with the expansion.
So in 1998, some gentlemen, they decided to try to determine how fast the deacceleration was. They wanted to be able to determine if the universe was going to expand forever at that particular rate. And if it was deaccelerating at a particular rate, then the gravity between the galaxies themselves would claim its grasp on the universe and essentially draw it back inward into a big crunch. And when I was in school, that was actually kind of attractive, because when people would say, yeah, well, where'd the Big Bang come from? You could say, the last big crunch. So the big crunch caused the next big bang. Or is it slowing down at such a rate where it is fast enough that it's just simply not going to ever be able to collapse in upon itself, and it'd be an open universe?
Yeah, it could get static
and
in its distances.
And it would just slow down, but it would go towards infinity. So at this particular point, they measured the redshift of the very furthest galaxies that they could, and they were able to determine this, and what they determined shook the foundations of physics.
Wow. Michael and Matt from the Branch Oak Observatory, and we'll finish up and talk about their event when we come back. KLIN 1499.
You're getting the 411 from DTL with Commander Jack Riggins on 1499.3 KLIN.
All right, folks, we got Michael and Matt in from the Branch Oak Observatory. They've got the season-ending star party tomorrow. Michael, we were finishing up a thought on a lot of big ideas.
Yep, absolutely. So we were talking about this discovery that these gentlemen made. They assumed it was a 50-50 proposition, that either the universe was open or the universe was closed, because they were looking at how fast the universe was deaccelerating, and here's where the big shakeup was. They discovered it wasn't deaccelerating. It's actually getting faster and faster. You have a firecracker on the ground. You light that firecracker. It moves really quick at first, but then it slows down. All the pieces drop on the ground, and that's kind of how the world works. Well, apparently not, because when we look at the universe is not only expanding very fast, but it's getting faster and faster and faster.
Well, what that could say to a common man is that we're still just viewing the very beginnings. Really,
we are. When you break everything into its most simple form in terms of matter and energy in the universe, only 5% of the universe is made up of atoms, baryonic matter, the stuff that we understand. So you, me, trees, buildings, stars, black holes.
That's 5%.
That means that there's 95% of the universe that is completely either we know very little about or nothing about at all.
Love it. Thank you, Matt.
All right, Branch Oak Observatory year-end star party tomorrow, 8 until 11. We have those Vortex binoculars. If you're not on Facebook, go to email us at info@branchoakobservatory.com. And, of course, when you're there, we'll draw for them as well. Vortex binoculars.
All right, folks, that's all we got time for. KLIN 1499.3.